Good afternoon, Rich Nass with Open Systems Media and leader of the Embedded Computing Design franchise. I'm here for another of the videos that we're shooting with PICMG to introduce the COM-HPC spec. As you've heard earlier, this is a huge deal for the embedded industry, the industrial computing industry, because we're going to push performance up a few notches. In this particular segment, I have Max Chi, who is the Senior Product Manager for Advantech, and he'll be talking about the journey to the COM-HPC client. So Max, how are you today?
Good. Rich, hi, how are you?
I'm good, thank you. So what does that mean exactly when you say the journey? Where are you going to take us with this presentation?
Okay, so basically COM-HPC has two specs, right? One is server and one is client. So today I'm gonna focusing on COM-HPC client, and I will introduce all the details regarding this and also how the COM-HPC client can benefit the market and the users. So here's the topic today, the journey to COM-HPC client. First of all, let's start with market trend. This year, 5G starts to be widely adopted around the world, and indeed, it changes the world a lot. It helped AI and IoT to make a big progress. So more and more devices are getting connected to the internet, and more data are generated. As a result, the demand of edge computing rises, and also the market requirements become different as the followings. First, connectivity. The Ethernet speed and I/O bandwidth need to go higher to transfer the data to the cloud. Second, latency. The response time needs to be fast, and now real-time becomes an important critical task. Third, performance. The computing power needs to be leveled up in order to shorten the time of data processing and analysis at the edge side. Fourth, scalability. While the world changes so quickly, it is important to be as quick as possible to adopt new technologies and make it time to market. So with those requirements, it all can show us that all the value markets can be impacted, and the equipment of each market needs to be upgraded in order to meet the requirement of edge computing. So we have mentioned new technologies are coming, right? So what are they? First, PCI Express Gen 5. It brings 32 GT per second, high speed, and it makes I/O revolution to provide you more possible usage. Then USB 4. It integrates USB, DisplayPort, and PCI Express signal all together with 40 gigabit per second bandwidth. So it makes USB a powerful but easy to use protocol. Next is display. The new HDMI 2.1, DP 2.0, and EDP 1.4b allow displays to be extremely high resolution, like 4K, 8K, and even the coming new higher resolutions. The last is Ethernet. 1 gigabit Ethernet is not enough now. So more higher speed, like 2.5 gig, 10 gig, 25 gig, or even 100 gigabit Ethernet are coming to meet the requirement of high-speed data transmission. So with those, all those new technologies require high bandwidth. And as the bandwidth goes high, how to deal with high-speed signals becomes an important critical task for hardware designers, because more signal pings will be used and signal quality needs to be well taken care. But please don't worry. This is why PICMG created COM-HPC 4, is to solve this. So the picture here shows you COM-HPC, a new standard with computer module concept. The computer module concept simplifies design and make development easier. So with the new COM-HPC standard, you can adopt new technologies in a fast and easy way. But you may be wondering how. Well, let's talk about the advantage of computer module concept. First, it simplifies system integration. So once the carrier board is designed, multiple modules can be used on the same carrier. It's one for all concept. Also, the modular thermal solution and fixed I/O design can give you easy migration and make the effort to change to new generation CPU smaller. Second, it secures core technology. Specific market know-how, technology, and protocol can be well secured on your carrier. And also, you can simply focus on your carrier board design to meet I/O and system requirements of your market. Third, it reduces design effort. While the CPU and the high-speed signals are designed on module and taken care by module vendors like us, you can shorten development schedule and lower development cost. And the most important thing here is time to market. The computer module concept lets you keep the same carrier board for multiple CPU generations. So one-time carrier design lasts for a longer period. Okay, so now we understand the benefit of computer module concept, and we know how COM-HPC use it. But how COM-HPC is different from the current existing COM-Express? Well, simply speaking, COM-HPC is not replacement to COM-E. Instead, it's complement to COM-E for higher end CPU, more memory, and faster I/O. With the current COM-Express type 6, 7, and 10, they are for general embedded purposes. However, the new coming COM-HPC server and client, they are at higher precision, targeting for high performance purposes. So with the current COM-Express and the new coming COM-HPC standard, the computer on module solutions can be full range covered. Okay, let's move to the main topic today, COM-HPC client introduction. So COM-HPC has 5 sizes, but actually COM-HPC client only use 3 of them, size A, B, and C. As you can see here, all the 3 sizes are with the same screw locations and board connector positions. So with one carrier design, you can use 3 different kind of modules. It's flexible and easy for migration. Second, CPU and memory are defined on the top side. So the heat generated by CPU and memory can be easily and better dissipated. Last, because all the mounting hole positions are the same, the thermal design can be unified and leveraged. And then let's move to the key features. The table here shows you the key features of COM-HPC client. Due to the time is short, I will highlight some important ones for you. First, PCI Express. COM-HPC client supports PCI Express Gen 5 with 32 GT per second high speed, and it gives you 48 lanes for more expansion options. The USB 4 integrate USB, PCI Express, display, and power, all the functions together to provide you flexible designability. Ethernet. COM-HPC supports 25 gigabit Ethernet for high-speed data transmission, and also it leaves optional IPMB support for remote control possibility. Last is power. This time, the COM-HPC is not limited to x86 processor. And because the CPU TDP is supported up to 100 watts, you can use more powerful processor like desktop CPU to have higher performance. On the other hand, COM-HPC also modifies embedded EEPROM spec to add new structure and increase the EEPROM size to store more information. And the most importantly, bus will be able to read EEPROM and adjust I/O configuration to match module and carrier settings. Now let's talk about bootable connector. As the picture here, you can see that COM-HPC has two types of connectors. One is for module and one is for carrier. For module, it's female type with 68.82 by 9 millimeter, and for carrier, it's male type with 68.82 by 8.75 millimeter dimension. For height, module connector is 5 millimeter high, and carrier connector has two options, 5 millimeter high and 10 millimeter high. As a combination of module and carrier, you have two options. If you want to have thin design, you can go for 5 millimeter high. You can also go for 10 millimeter high if you want to have more components to be implemented on carrier. The new bootable connector is with 400 pins and total is 800 pins. Because we have 800 pins, it can support more IOs. And also the connector itself is high-speed rated. So it can support higher input power up to 358 watts. And also it can support high-speed IOs with the new generation and new standard IOs. Then let's talk about mechanical. Before starting to explain this picture, I would like to highlight one thing first. COM-HPC only defines heat spreader as a standard thermal solution. However, the COM-HPC leaves option for module vendors like us to make semi-heatsink or semi-cooler to be used on top of the heat spreader. So back to the picture here, COM-HPC defines two different kinds of screws. First is M2.5. It's for heat spreader plus module plus carrier, like the red ones in the picture. Another one is M3 for heat spreader plus semi-heatsink or semi-cooler as the green ones in the picture. You might be curious about how the system will be assembled. As the picture on the right-hand side, first, we place module on carrier. Second, we made bootable connectors uniformly. And third, you assemble heat spreader, module, and carrier board all together by the mentioned M2.5 screws. And that will be the standard thermal solution or standard mechanical that COM-HPC defines. The total height of heat spreader plus module plus carrier have two options. If you go for 5 millimeter high bootable connector, the total height will be 22 millimeters. And if you go for 10 millimeter bootable connector, the total height will be 27 millimeters. As I mentioned before, except heat spreader, module vendors like us can provide heatsink, semi-heatsink or semi-cooler to be attached on top of heat spreader. So if you want to do so, look at the blue side and you can screw them by the M3 screws. And then let's talk about thermal solutions. Like mentioned, with the standard heat spreader, we can attach semi-heatsink or semi-cooler on top of heat spreader as a complete standard thermal solution. And also, it's possible for module vendors like us to provide you one-piece cooler or even a fully customized thermal solution to meet your system requirement. Then, COM-HPC has prepared some reference documents for you. First is module-based spec. It's mainly for module design, and it defines all the technical details, including feature, pinout, signal quality, power, and mechanical. Also, for users like you, COM-HPC also prepared carrier board design guide for you to design your own carrier board. It is with reference information like schematic, layout, and I/O implementation suggestions. And lastly, COM-HPC prepared software spec. First, like the mentioned, embedded EEPROM spec, and also the IPMI spec, or so-called platform management interface spec, for you to use if you want to implement remote control ability in your system. But that's not all. Module vendors like us, Advantech, can provide design guide and checklist for every single module or platform. Also, we will be able to provide you services like schematic review and layout review to shorten your development schedule and make it time to market. Okay, that's all about COM-HPC client spec. Finally, let's check how the COM-HPC client can benefit you. First, let's start with technology usage. With the new USB 4, you can simply use one Type-C connector for multiple different usages, like power adapter, or you can connect to monitor, you can connect to external storage, or even using external high-end graphic card. Also, USB 4 is fully compliant with Thunderbolt, so it can give you more possible design abilities. Next is PCI Express Gen 5. With the 32 GT per second high speed, you will be able to connect to the latest expansion cards or devices like FPGA, NVMe, AI acceleration card, GPU, or BMC, and so on and so on. And also because the speed is very fast, it also leaves you the possibility for future technologies or future usages. While the COM-HPC client brings new technical usages, the COM-HPC client can also benefit the market. For example, medical. With the larger board size and higher CPU TDP support, it can use high performance CPU like desktop CPU for high performance along with scalability and flexibility. 5G. With the new high-speed PCI Express Gen 5 and 25 gigabit Ethernet support, it allows you to connect to the latest FPGA card, and also with the high-speed data transmission for edge computing. Gaming. Because the new portable connector and high-speed IOs, next generation IOs, with those, you will be able to use the extremely powerful next generation graphic card with smooth 8K display. These are just 3 examples showing how the COM-HPC client can benefit and offer you. But in fact, all the vertical markets can benefit from the new features, enhanced functions, and faster IOs of COM-HPC. So that's about the end. But before we finish, let's quickly do a small wrap up. So today we've talked about how the market and technology change, why PICMG created COM-HPC, what is COM-HPC, and how the COM-HPC can benefit you. Again, COM-HPC is complement to COM-Express for high-end CPU, more memory, and faster I/O. The purpose of COM-HPC is to offer complete computer on module solutions. Now, the PICMG and all members like us are doing final work, and we expect to release spec and design guide in Q1 2021. Lastly, module vendor like Advantech, we have complete COM-HPC product roadmap, and we will release right after the spec release, also in Q1 2021. So that's all for my presentation. Thank you.
Interesting presentation. I did have one question for you, though. There was one thing you said that I'd like to ask. You said that there was a reduced design effort with COM-HPC. Why is that?
Because like I mentioned, a lot of new technologies coming, and they are all high speed with a high bandwidth, right? So a lot of effort will be, if you are going to implement new technologies, it must be a lot of challenges, especially for the high speed signals, right? So because the CPU itself and also all the IOs coming from the CPU are designed and implemented on the module. So for carrier board users, or we can say the market users, they can simply design their carrier board without considering those difficult high-speed signals.
That's very interesting. Okay, well, see, as I was supposed to, I learned something in this video, and I'm sure I'll learn something in all the videos. As I said earlier, this is one of 8, and I encourage you to watch them all. They're all sponsored by PICMG, and they're all about COM-HPC, and you will learn something from each one. This video featured Max Chi, a senior product manager with Advantech. So have a great day, everybody.